Hey everyone, welcome to our next section. We're on solving quadratics this time. This will be our last unit through the quadratic section and just kind of an introduction into what quadratics can do and how we can use them, particularly to help us find the roots. So we have kind of a set formula that you can see up on the board. It does look a little bit intimidating, it's large, but really once we dive into it, it's not that bad. So basically, the quadratic formula comes about by this process called completing the square. And it's something that if you haven't already seen it, you will. And basically, completing the square helps us to determine out what these roots can be for different equations. So it's basically just a way to find roots. That's all the quadratic does in the end, is tells us how we can figure out what these roots are, and there's a lot of neat characteristics that kind of pop up within the quadratic that help us take a look at things a little bit more closely and to see what they are. So without getting too much into it, let's practice a little bit on how we can use the quadratic to solve some of these equations. So in our first example, it's here, it says connecting the quadratic formula to factoring. So to solve the following equation. And basically what we can do here is we can actually factor this one out. And realistically, when you factor, or when you look at a quadratic and you can factor it, you should. It's a lot faster than going through maybe some of the other methods that can solve for these roots and what they are. So let's take a look at this with the quadratic equation and see what happens. So we have our quadratic. And first we need to kind of make everything equal to 0. So if I go back to here, this is the initial setup. We always have to make everything equal to 0. And then once we make this equal to 0, we have an A term, a B term, and a C term. And then all we do is we just plug those values in for our corresponding letters, and we solve for what we need. So first thing I need to do here is to make this equal to 0. 6x squared. I'm going to take the 7x and minus it over to the other side. So 6x squared minus 7x minus 3 equals 0. So now I have this form of ax squared plus bx plus c equals 0. And particularly I have a equal to 6, we've got b equal to negative 7, and c equal to negative 3. Okay, so I have these relationships right there. So I'm going to write out our quadratic formula that we have. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. It is important that when you put it over 2a, the whole thing gets divided by 2a. Sometimes I find that people just kind of put it under one term and forget about it. It is over the whole fraction. So our next step is just take those numbers and plug them into the spots where the letters are. So negative, and then b is a negative 7. So I'm going to put in negative 7. I'm going to use brackets to surround each of my terms. It just makes it easier for them to stand out. So b squared, I've got negative 7 squared minus 4 times my a value, which is 6, and my c value is negative 3. The whole thing gets square rooted, and remember it's all over 2 times a, which is 6. So x is equal to, now we start to simplify this. A negative times a negative is a positive, so there's 7 plus or minus the square root. Negative 7 squared is 49. And then 4 times 6 times negative 3. 4 times 6 is 24. And 24 times 3 gives me 72. So I have a negative times a negative in there, so this is going to be plus 72. The whole thing again, all over 12. Now what I have is I have 7 plus or minus 49 plus 72 is 121, all over 12. We can take the square root of 121, that's 11, all over 12, and then we're almost there to be done because we can then take a look at this thing. Actually, I'll erase that for now, because then we can take a look at this thing in terms of this plus or minus part, which we haven't really talked about yet. So this plus or minus symbol right here means that that you can solve this in two different ways. We can solve the plus version of this equation, and we can solve the minus version of this equation. And so really we have to break this apart into two separate equations, or two separate parts. We can do the plus side and then the minus side. So x is equal to 7 plus 11 over 12, which really means that x is equal to 18 over 12. And then I can simplify this down. It looks like both of them are divisible by 6, so I can simplify this down to 3 over 2. The minus side of this equation, I'm going to have x is equal to 7 minus 11 over 12. Looks like I'm going to get negative 4 over 12, which is really just negative 1/3. So that means that I have my two roots. I have what my two x-intercepts are. They cross over at 3 over 2, and they cross over at negative 1/3. And so, using the quadratic, I can actually determine roots for any quadratic equation, and it will tell me where it crosses the x-axis. Now, this also said solve the factoring and make the connection to factoring as well. So, if we were to make a connection to factoring with this, we're going to start back up at the top, and we're going to take a look to see how we could factor this out to get the same answer. So, if I started off on my second line here, 6x squared minus 7x minus 3 equals 0. What I'm trying to figure out here is what can I use for two terms that multiply to give me negative 18. So remember, the a and the c term multiply, so two terms that multiply to give me negative 18, and those same two terms are going to add to give me negative 7. And so negative 9 and positive 2 pop up. Negative 9 and positive 2 would give me that negative 7. So I'm going to expand this out. I'm going to write 6x squared minus a 9x plus 2x minus 3 equals 0. The next step would be to bracket your first couple of terms and your last two terms. I'm going to common factor this out. So that means I have a 2x, it looks like, or sorry, a 3x out of the first one. So a 3x comes out of the first one, and I'm left with 2x minus 3. Now, I don't factor anything out of the second term because there's nothing in common. So this is just 2x minus 3. And then this whole thing equals 0. So now I have a 2x minus 3 in common. So I'm going to factor that out, 2x minus 3. And then what's left over is 3x plus, and then there'd be a 1 in the front there. So 3x plus 1. Then I can take a look at the roots for each of these things. So if I take a look at this one, we're saying 2x minus 3 equals 0. That means that 2x is equal to 3, which means x is equal to 3 over 2. If I take a look at my second one, I've got 3x plus 1 equals 0, which means I have 3x is equal to negative 1, which means x is equal to negative 1/3. Now if I take a look at my roots, I've got 3 over 2, I've got 3 over 2, I've got negative 1/3, I've got negative 1/3, and you can see how this quadratic is going to pop out what those x-intercepts are, what those roots are. It's faster if we can go through a factoring method, and I would always encourage that if you can factor, do that first. It saves you a lot of steps. But if an equation doesn't seem like it can be factored, we can actually still use the quadratic to come up with the correct answer. So, to determine the exact solution to a quadratic equation. So in this one, we need to find out what an exact solution is. And basically, an exact solution just means no decimals. Okay, we're looking for something that's going to be an exact value. So if I need to take the square root of 18, for instance, I'm not going to say that it's 4 point something something something. I'm going to leave it as the square root of 18. So What I would like for you to do is to pause the video, and it's already set up, so just try to see how far you can get, and then unpause and come back when you're ready. Alright, so we have, in this case, a equal to 2, we have b equal to 8, and we have c equal to -5. This thing's already equal to 0, and that's the only reason why we can do that quadratic now, because remember, when we're finding x-intercepts, y is 0. So our quadratic, x is equal to -b plus or minus the square root of b squared minus 4ac, and then that whole thing is over 2a. So we're going to plug in our values, -8 plus or minus the square root of 8 squared minus 4 times 2 times -5, all over 2 times 2. X is equal to, and then I'll have -8 plus or minus the square root of 64 plus 40, all over 4. X is equal to -8 plus or minus the square root of 104 over 4. So it's at this point that it's fairly common that I see a lot of people want to divide that 8 and 4. We can't do that yet because we have different terms here, and every term has to have a value in it before we can cancel it out. So at this point, I'd actually have two exact values. It's just not reduced down to its lowest term. And so we have to check and see if this 104 can reduce down into something that we can factor out. So if we were to take a look at 104, okay, 104, and try to see what it has for multiples, can I find a multiple that has a perfect square? Because if I can, then I can take the square root of it. So 104 can be broken apart into 2 and 52, which can then be broken apart into 2 and 29. Sorry, not 29, 2 and 26. So that means that if I take the 2 times 2lets here, if I take 4 times 26, I'm going to get 104. Now, if I have the root of 104, that means that really I have the root of 4 times 26. I know the square root of 4, so really what I have here is the square root of 4 times the square root of 26. And this part actually starts to deal with a little bit of stuff called radicals, which comes up later on. But basically, all you need to know from this step, or this part, is that all I'm doing right now are finding factors of 104. And I'm looking for one that's a perfect square, so I can take the square root of it. So I found a factor, 4 and 26, and 4 just happens to have a perfect square, so I can take the square root of 4. When I take the square root of 4, I get 2, and then I'm going to have root 26 left over. And so if you check it out on a calculator, it actually works. If I take the square root of 104, you get 10.19803 and change. If you took the square root of 2 times the root of 26, you get 10.19803,903. It just keeps going. So it does give me the same value. And all I did was I just broke apart into its factors and then just basically looked for a perfect square that I could take the square root of. So I can use this over here. Now I have x is equal to -8 plus or minus 2 root 26 all over 4. So that means that x is equal to, and then I'm going to take a look at the 8, the 2, and the 4. And now because I have these numbers that are kind of whole numbers with them, I can then take out a common factor. So out of each one, 8, 2, and 4, they all go evenly into 2. So I'm going to reduce this and divide each one by a 2. Okay, I'm going to reduce those numbers. Now I'm going to write what's left over. So I've got -4 plus or minus 1 root 26, that's just root 26, over 2. Now I have, I can't simplify this any further, so I'm going to separate this out into my two roots. I've got a positive root and I've got a negative root. my positive root, x is equal to minus 4 plus root 26 all over 2, and then x is equal to minus 4 minus root 26 over 2. So those are my two roots, and they have exact values. They're not just given out as decimals, they have exact number answers to them. So I'm going to end this video here. We still have a couple other examples left to go through, but hopefully it gave you a chance to familiarize yourself with how the quadratic equation works.